Solving inequalities. The nice thing about solving inequalities is it's not that different from solving equations. So a lot of the skills we've already learned, we can just continue to apply. For example, if we have 1/7 plus d is less than 1 2/7, we can simply subtract 1/7 from both sides and find that d is less than 1 1/7. With inequalities, even combining like terms is similar. For instance, negative 2p minus 4 plus 3p is greater than 10. Notice on one side of the inequality we have negative 2p and positive 3p. Those are like terms, here and here. And we can combine those like terms. 3p and negative 2p give us 1p, and negative 4 gives us p minus 4 is greater than 10. Adding 4 to both sides, we get p is greater than 14. Notice both of those are working exactly like an equation might. We're just keeping consistent with the sign that we have. Greater than, greater than, greater than. For the most part, it's even true with multiplication and division. If we have the inequality x over 3 is greater than negative 1, to solve this, since x is being divided by 3, we can simply multiply both sides by 3 and find that x is greater than negative 3. However, this changes in the problem negative 18 is greater than or equal to negative 6c. Here it's different because you'll notice that the coefficient negative 6 here is the coefficient on c, negative 6, is negative. And when we have to divide by a negative, which we're going to have to do here, because remember the connection between negative 6 and c is multiplication. So to get rid of this negative 6, we have to do division. We have to do the inverse operation, which is division, to remove that negative 6, so to break this connection. But to do that, we're going to have to divide by a negative. And this is the one place it gets a little bit different with inequalities. You have to remember that anytime you divide or multiply by a negative, you have to flip the sign. And when I mean flip the sign, I mean this inequality sign has to go the other direction now. So in this case, we divide by negative 6, and we get, over here we get positive 3, and over here we get c. And rather than 3 is greater than or equal to c, now we flip the sign, and it becomes 3 is less than or equal to c. So when we divide by a negative, we have to remember to reverse that sign. Notice here, it's greater than or equal to, and then we reverse it. We turn it around here, and we have less than or equal to, all because we divided by a negative. The same is true if we have to multiply by a negative. In the case of 4 is less than or equal to negative p over 2. Now, initially, it's not necessarily clear that the p or the 2 is negative. In fact, we have our choice as to which to assign. In this case, it's easiest to make the 2 negative and just deal with the 2 and the negative sign all in one procedure. So I'm going to multiply both sides by negative 2. Again, just like I was solving an equation. In this case, the negative 2's cancel out on this side, and negative 2 times 4 is negative 8. So we have p and negative 8. The important thing to notice is, look, I'm multiplying by a negative again. Well, actually, last time I was dividing, but this time I'm multiplying by a negative. So when I multiply by a negative, much like when I'm dividing, I have to turn my sign around. So rather than less than or equal to, now it's going to be greater than or equal to. So negative 8 is greater than or equal to p. Let's look at what happens when we have to do multiple steps in one inequality. So One of the things I'm going to be watching for, just like when I was solving equations, is avoiding those negative coefficients. In this case, when I want to get my v's on the same side of the inequality here, I'm going to start by subtracting 3v. The reason I do this is because I want to avoid having to worry about flipping the sign. So if I can keep my coefficient positive, I don't have to worry about flipping the sign. So negative 12 is greater than 5v minus 3v is 2v plus 10. I can subtract 10 from both sides. Negative 22 is greater than 2v. Divide by 2, divide by 2. Negative 11 is greater than v, or v is less than negative 11 if I were to turn that around. Notice I didn't have to flip my sign at all throughout this whole process because I never had a negative coefficient on v. I always had a positive coefficient. If I had had a negative coefficient at some point, then I'd have to worry about flipping my signs. It solves very much like an equation, especially when you avoid those negative coefficients. Also, like equations, we can have no solution or all solutions. So it depends on how the inequality comes out. Much like an equation, if the inequality solves to something that is absolutely true without a variable, then it's all real solutions. If the inequality solves to something that is absolutely false with no variables, then it is no solutions. Let's look at an example. We have 6w plus 5 is greater than 2 times 3w plus 3. First thing I'm going to do is distributive property. So I still have 6w plus 5 on this side is greater than 2 times 3w is 6w, 2 times 3 is 6. I'm going to subtract my 6w from both sides. Now watch what happens. I end up with 5, because this cancels out, and this cancels out, is greater than 6. Well, last time I checked, 5 was not greater than 6. So this is not true. So this would be a perfect example of no solutions. Well, why is it no solutions? Well, because no matter what number I would replace w with in this inequality, no matter what number, it would always come out false. So there's no value for w for which this inequality is ever going to be true. So that's an example of no solutions. Another example is negative 5r plus 15 is greater than or equal to negative 5 times r minus 2. If I do my distributive property again, like I did in the previous problem to simplify the one side, I still have negative 5r plus 15 is greater than or equal to, on this side I have negative 5r plus 10. If I add 5r to both sides, these both cancel out again. And I'm left with 15 is greater than or equal to 10. Well, that's true no matter what. 15 is always greater than or equal to 10. So this statement is always true no matter what value I would pick for r. So in this case, it's all real solutions. R equals, and we can do our all real solution sign, or you could just say all real solutions. Either one of those would be acceptable answers. I like this because it's nice and short. R equals all reals.